Good morning, my dear students. So, as I have uploaded my first video regarding machine drawing part A section of solids. So, this video is in continuation with my previous class. So, today we shall solve second problem on section of solids. So, let us start now. So, this is the second problem on section of solids. The statement of the problem is like this. A square pyramid of base side 45 mm and axis length 70 mm rests on its base on the HP in such a way that all of its base edges are equally inclined to VP. Full stop. It is cut by a section plane perpendicular to VP, inclined at 45 degrees to HP and bisecting the axis. Full stop. Draw its sectional top view, sectional side view and true shape of section. So this is the statement of the problem. So let us analyze what are the given data. So first of all, the solid is a square pyramid. It is a square pyramid. It is resting. How it is resting we have to find out. It is resting in such a way that it is resting on its base. The base sides measure 45 mm. How much they measure? They measure 45 mm and the axis length is 70 mm. Axis length given is 70 mm. It rests on its base on the HP in such a way that all of its base edges are equally inclined to VP. So the square pyramid, all the base edges of the square pyramid are equally inclined to VP. This is the first condition that we have to note. The second part of the statement is, it is cut by a section plane perpendicular to VP inclined at 45 degrees to HP. The section plane is inclined at 45 degrees to HP. This is the third data. And bisecting the axis. This section plane which is inclined at 45 degrees to HP bisects the axis, which is bisecting the axis. So these are the things that we need to find out. We need to find out its sectional top view, sectional side view and true shape of section. So these are the given data in the problem. So we shall start drawing the solution for this problem. So let me start now. So let me start drawing the problem. So I shall start first as so we shall start with the solution of the problem, right? So it's a problem on square pyramid, as you know. So first of all, let me draw the XY line. So we shall draw the XY line. So this is our XY line. So extend it on either side. So let me name the XY line as X, Y. So this is our XY line. So let me name the vertical plane VP, horizontal plane HP. Right? We shall start solving the problem. So a square pyramid of base side 45 mm. So all the base sides are equally inclined. So to satisfy this condition, first of all what we should do is, we should just take a reference line, small reference line, and put a point here and draw the top view of the square pyramid, which is of 45 mm sides. So I need to draw a square pyramid in which all the base sides are equally inclined. So the procedure, as we know, is to see that all the base sides are equally inclined. So what I am doing is, I will measure 45 degrees on either side of this. So I will measure 45 here also and just draw thin lines so that I will erase it afterwards. So this is, since it may not be visible, I'll just draw a little bit darker. Now the base side measures 45 mm. So I will take the compass and measure 45 with my scale. I will measure 45, take a distance of 45 mm. Keeping this on this point, I will just cut here, and now the other two sides will measure 45 also. So I will cut from this arrow and try to construct a square pyramid, the top view of a square pyramid, which is a square. So this is the top view of a square pyramid, which looks as a square. So now all the sides are equally inclined, so therefore that's why we should draw the top view in this condition. Now I will just try to erase the extra lines so that they may not lead to confusion afterwards. So I'll just erase these extra lines, and let me name this square pyramid, the top view of the square pyramid now. So let me name it is the first corner A, this is B, this is C, and this is D. Now let us find out the center point. Okay, so just drawing the opposite corners. So we get the center point of this square. So let me call that point as O. So this is the top view of a square pyramid which is equally inclined, and all the sides measure 45 mm. So let me indicate that the length of these sides measures 45 mm. How much they measure? They measure 45 mm. Now I shall draw the front view of this square pyramid. So I'll just project these lines. Now this is the projection lines that I have drawn from A, B, C and D. The height of the square pyramid is 70 mm. So from the center or from the axis, so here you have to measure the height, that is the length is 70 mm. So let me measure 70 mm. So this is the height of 70 mm. Now join the projection lines to form the front view of the square pyramid, which looks like a triangle. Let the apex be named as O dash, since it is the front view. Now corresponding points A, B, C and D have to be named. So let me name them. So this is A dash, this is B dash, this is C dash and D dash in the bracket. So this is the top view and the front view of the problem. Now we need to draw the side view of the square pyramid. So to draw the side view, we will draw the profile plane. So I will fix the profile plane at a certain distance. Let me call this as the profile plane. The profile plane is denoted as x1, y1. So this is your profile plane. Now with the help of protractor, okay, we draw a 45-degree line from this origin where the xy line and x1, y1 line meet. So take an inclination of 45 degrees and draw. This is the 45-degree line. This inclination is 45 degrees. Let me indicate here the height of the height. The height is 70 mm. It is 70 mm. Now draw horizontal lines, projection lines. So from A, B, C and D, like this. They intersect the 45-degree line, and later we need to obtain its side view. To obtain the side view, what is the procedure? Again project them in the profile plane like this. And draw line from the front view so that you get all the points. Now trace out these points A, B, C, D here. So corresponding lines from where they come, A. So this is the point of A. So this is what A double dash. B is here, it's coming here. So therefore B is coming here. So this will be B double dash. C is coming on the same line as A. Where is C? So this is C. So let me write this as C double dash. Okay. So then D is coming here. So this is D. So this is D double dash. And O is coming over here. This is the point or line where O intersects. So this is O double dash. Now let me join all these points to form the side view of the square pyramid, which is also a triangle. So this is the side view of the square pyramid. Now we need to draw the section plane. So the condition given in the problem is that the section plane is inclined at 45 degrees to HP and is perpendicular to VP. This is bisecting the axis. So therefore, since it has to bisect the axis, so this is the axis of the pyramid. So we shall find out the midpoint of the axis. So definitely, since the height of the pyramid is 70 mm, so midpoint lies exactly at a distance of 70 by 2. So I shall measure 35 mm from its apex. So 35, I get the 35 mm line here. So I'll just show that this distance is how much? This distance is 35 mm. So your axis line is to be bisected. So therefore I write this as 35 mm. Now our section plane has to be drawn from this point of bisection. So we shall draw the section plane which is inclined at 45 degrees to HP. So now I place my protractor here. And measure the inclination of 45 degrees. So measure 45 degrees. Right. Now draw a line connecting through this bisection point and the 45 degree line. So it has to be drawn at an inclination of 45 degrees. So you just this is the section plane. So follow the convention for section plane. One continuous line and one, right? So this is your section plane. So as I said in my previous problem, section plane has to be indicated as SS. So show the arrows, draw the arrowheads, lines, and this is your section plane, and that's why I indicate it as yes. Now this section plane, the section plane cuts the square pyramid in the front view at this point as well as at this point. So what are those points? We have to name them. So since this is a slant edge OA, so let me start from here. Let me call it as 1 dash. Similarly, let me call it as 2 dash. This one, this point cuts here, so let it be 3 dash. And another point is there, so it is called as 4 dash. So this is 4 dash. So since 2 dash is corresponding here, so we shall name it. Okay. So 2 dash is for B and D is for, let me name it as 4 dash and keep it in the bracket. So this is the section plane where we have drawn, and it is inclined at 45 degrees. So I can show that 45 degrees here. I will show that it is inclined 45 degrees. You can show either here or you can show here also. And it is bisecting. So I have drawn at a distance of 35 mm. Now I will draw projections from these points 1 to the top view. So let me draw projection lines from 1 dash. So this point is for OA. So this point is called as point 1. Now from 2 dash again I will draw projection. So since I cannot get, because it is a vertical line, I cannot put where the point 2 lies. So what procedure we have to follow is, so you should draw a small line here. Draw a horizontal line like this. Draw a horizontal line. See, draw a horizontal line from 2 dash to this slant edge. Then draw vertical projection line till we meet this diagonal AC, and with the help of the compass, measure the distance O from this point and try to cut an arc on either side, this side, left side, as well as to the right side. So these points are to be named. So therefore, since it is OB, this is the median, okay. So here we name it as 2. So this is for D, which is the fourth corner of the square pyramid. So let us 4, right. So 1, 2, 4 are obtained. So 3. So from 3 we draw a vertical projection line again back to our top view. So this is our point 3. Now join all these points 1, 2, 3 and 4. So I'll just join. So please note down carefully. 1, 2, 2, 3, 3, 4 and 4, 1. Right. Now this is the sectional top view of the square pyramid. So we should draw inclinations at an angle of 45 degree. So just draw 45 degree lines at a distance of 2 to 3 mm. So 2 to 3 mm distance you follow and hatch it. So which indicates that it is your sectional top view. Right. This is your sectional top view. Now the second part of the problem, that is we have to find out the sectional side view. Now to find out the sectional side view, draw the lines, projection lines from these points 1, 2, 3 and 4 to get the sectional side view. So since 1 is on this line, so my point 1 where it will come, I have to trace out. So 1 is coming over here. So 1 is here. So from the front view of the square pyramid, I will draw horizontal line. So this is 1 double dash. So correspondingly 2 double dash. So 2 double dash is here. So I'll just draw horizontal line from 2 dash. Right. So 2 dash is here. So I will also try to find out where it will come. Project it onto 45 degree line. Slowly draw parallel line above here. Right. Next you see that they will meet like this. So this is your point 2 double dash. So name it as 2 double dash. Similarly, where is 3 double dash? So 3 double dash is also coming on this line. So 3 double dash is here. So draw a projection lines from 3 dash in your front view such that it will intersect in the side view here. So this is the line coming. So this is the point, that is 3 double dash. So this is 3 double dash. Similarly, 4, from 4 we draw line. We draw a line and extend it. So it will meet here. So this is 4 double dash. So these are the points 1 double dash, 2 double dash, 3 double dash and 4 double dash. So just let me draw it little. I'll just erase it and draw the lines little bit so that darker, so that they are visible for you. So just, I hope it is visible now. Now let me name it as 2 double dash. Right? I will join these points 1 double dash, 2 double dash, 3 double dash and 4 double dash in my side view. So this is what we get, and this is our sectional side view. This is our sectional side view. With the help of sectional top view, we have traced our sectional side view. So let me do again just hatching. So I'll just hatch it. So hatching should be done at a distance of 2 to 3 mm. So this is your sectional side view. Now we should draw the true shape of the section. So let me move to draw the true shape of the section. So here you can draw the true shape of the section either this side or this side. So since if I draw it here, it will get overlapped. So just I will take a line parallel to this section plane. So let me take at any convenient distance. So like this, okay. So let me take this as a line parallel to axis or the section plane. Let me name it as x2, y2. Let me name it as x2, y2. Now draw perpendiculars from these points 1 dash, 2 dash, 3 dash and 4 dash. So I will draw perpendiculars. So this is my plane x2, y2 parallel to the section plane. So with the help of protractor, draw perpendiculars from these points where the section plane cuts the front view of the pyramid. So place your protractor on those points exactly such that they are perpendicular. So 90 degree. So like this. So even from 2 and 4, draw perpendicular lines, and from 3 also. So like this. Now I will join these lines so that they are perpendicular to those points. One thing we have to remember here is that x2 y2 line will be parallel to the section plane, and these projection lines will be perpendicular drawn from those corresponding points. This is very important. Now in order to find out the true shape of section, with the help of compass we need to measure the corresponding distances of the points 1 dash, 2 dash, 3 dash and 4 dash from the xy line to that points in the top view, sectional top view. So now I will start from here. This is the line, projection line coming from 1 dash. So this is the point where it intersects. So you need to test where it is intersecting. So this is the point. So from this point I shall measure the distance from here to point 1. Now keeping this on the perpendicular line coming from 1 dash and meeting around x2, I will cut an arc. So since the lines are smaller, you can also extend them. So please extend those lines. Extend the lines a little bit longer because the distance is a little bit more. So we extend to some infinite length. Now it has cut here. So let me name this point as 1 suffix 1. This is 1 suffix 1. Similarly, we follow the same procedure for tracing the other 3 points. So now from B, why? Because this is the point 2 dash, this 1. Okay, so from here I will measure the distance 2. Again from this line 2 dash I will cut. So this is the point 2. So therefore call it as 2 suffix 1. This is 2 suffix 1. Now the same point, we have another point, that is 4. So measure the distance between that point and 4. So similar way, keeping on the same point, cut here. So this will become 4 suffix 1. Now follow the same procedure for tracing the other points like the 3. So this is 3 dash, 3 dash. So this intersects at this point. So from this point, measure the distance from here to 3 and place it on the perpendicular line that intersects the XY line here and cut it. So this becomes 3 suffix 1. Now join all these 4 points. See here, I am just drawing all these 4 points. Join all these 4 points. So I am joining now 3 and 4, now 2 and 1. Right. So this is the true shape of section of the square pyramid. So hatch it. So as you know, hatching should always be done at an inclination of 45 degrees. So just draw inclination of 45 degrees. So this is how we will hatch it. The hatching should be done. So I am just drawing the hatching line to indicate that this is the true shape of section. This is the true shape of section. So this completes this problem after you hatch it, which is the final step that you need to find out. So this is the true shape of section. So I shall show that this is the true shape. So I will write it here, true shape of section. So this is the true shape of section. So this completes the problem. This is the final solution of the problem.